All right. This is on your homework. We're going to do it together.
Yay!
We did this one yesterday.
Oh, we did.
No, we did not.
One minute.
Be quiet and try to learn something.
Okay.
Oh, no way.
Okay, this one's a little bit different, so I want to do it with you. Not too much different. Why are you up?
Generating trash.
Okay, you have your little steps with you? You should still be using the steps because we're still screws. We have not mastered balancing redox reactions yet.
All right, I got stuff on this row.
What's today's date?
It's my first time. And if I'm walking in the house, it's not.
Okay. In order to separate them into half reactions, we have to figure out the oxidation state of all the elements in the equation. What's the oxidation state of the oxygen? 2 minus. So what's my chlorine? 5 plus. What's my chlorine here?
One minus.
And what's my chlorine here?
0.
0. Y'all understand why that's 0?
Yeah, because
It's
it's a
in its
mod.
most stable form.
Yeah, it's a monotonic.
No, it's not a monatomic ion.
Never mind, it's 0.
Ions have charges.
4 plus and 2 minus.
No.
2
What?
minus and 4 plus.
Oxygen is
Oh, Lord.
Minus.
2 minus, and the chlorine,
4
4 plus.
Brenda said that.
It wasn't the order that I wanted it in.
Don't be that kid. Or that teacher.
Oh, yeah, don't be that teacher.
But I am that teacher.
Don't.
Gotta remove
All right. Just looking at it, a little bit of common sense. If you're trying to figure out what the half reactions are, we have this species here. We're separating it into half reactions. What is it most likely to be with? This or this? Why the second one?
Because that's oxygen.
Yeah, it's still bonded with the oxygen, isn't it? And here we have the chloride ion. That's more likely to go to the molecule of chlorine gas. Okay? All right, so chlorine here is 5 plus. It's 4 plus here. Is that an oxidation or a reduction?
Oxidation.
How do you know?
It gained an electron.
You're
It became a positive.
It lost the proton. It's a reduction. It's a reduction of the gain.
it's becoming more negative. So that is our reduction. Right?
Yeah.
I like to write the oxidation first. So Cl, 1 minus, going to Cl2 with oxidation state of 0. That's an oxidation. That has lost an electron. So I'm going to write that first. Okay, that's my oxidation. And the reduction is going to be this going to this. So ClO3 minus going to ClO2. Okay, that's my reduction. Grr.
You're all bad. You're bad.
What's the next step, Brenda? Balance what? They're not all balanced.
Add H2 on the
Oxygen in water.
No, there's something before that.
Add H2O. Oh no, you add 2.
All of the elements that are not oxygen or hydrogen are not balanced.
And then
Oh,
2 is added 2.
don't get ahead of yourself. Because you're irritating me. You never stop talking. All right, now what's the next step?
Add
Add water
H2O to CO
to balance all the oxygen.
Okay, well, I don't have any here, so I guess we're good. Here I have 2 oxygens, here I have 3. What should I do, Brenda? I asked you when you're not talking, that means,
You add 1, 2, no, 1 H2O.
which side? Okay, next step.
Balance the hydrogen.
Balance the hydrogens by adding,
Add 2 hydrogens on the
so we'll put a couple of protons over here. All right, now what? Balance electrons, okay? Here I have the chloride ion going from 1 minus to 0.
You have 1 electron.
Add 1 electron.
Yes.
Does everyone agree with that? Amy, do you concur? Anyone have a mind of their own? Anna Leaner, do you concur? Anyone? Crayon?
What's your curve?
Agreed.
Oh, well, I concur.
You concur?
Oh, no,
It's good to know what a word is before you agree to it. Yeah.
Don't need 2 electrons?
Yeah. Lena,
Oh, so you need
you disagree? Are you going to take the contrary position? What do you think it should be? Why? Somebody give Lena $1. It's 2 electrons. Why is it 2 electrons? We're dealing with 2 chlorines. It's 2 chlorines. We got 2 here going from 1 minus to 0. There's 2 here, so it's going to take 2 electrons to do that. Does that make sense? That's the reason I want to do this problem. Okay? Alright, it doesn't make sense? There's 3 in the back. Leslie? I have 2 chlorines. 2 chloride ions going to 2 chlorines bonded together as a molecule. 2, 1, 2. And each chlorine is going from 1 minus to 0. So it's going to take 1 electron for each atom. 2. Okay? All right, what about down here? I'm going from 5 plus to 4 plus.
I want an electron.
1 electron on the reactant side. Very good. Okay, just a little tip. I like to be consistent, and if you do things the same way every time, after a while it becomes muscle memory, and you don't have to stop and think about it so much. You don't have to waste time once you know how to do something. I always write the oxidation first, and then the reduction, and then without even thinking, I know for the oxidation, the electrons are going to be on the product side. The reduction, the electrons are going to be on the reactant side. I don't have to stop and think. I can just figure out how many electrons and go. Okay? Because I do it the same way every time. All right. What's the next step? We're going to multiply the bottom one by 2 to get the electrons to balance. So 2e, 2 times 2, unless there's been some changes in math, is 4. Have there been any changes in math?
No, it's still 1.
Okay, now what? Cancel stuff? Hold on. Julia has a question. To get my electrons to balance. I had 2 electrons up here, I only had 1 down here. So the electrons have to balance because if something is losing electrons, something else has to gain the electrons. They don't just disappear on us. That's the whole point of going through this, actually, is to get to that step where we balance electrons. Shut up. All right, what cancels?
Only the electrons.
Only the electrons.
Yeah.
So we have 4 hydrogen ions plus 2 chloride ions plus 2 CL. Oh, that's ugly.
Yeah.
Sounds shocking.
Normally my writing is like calligraphy.
You're hilarious.
And your S's.
Your G's are the best.
And it's D's.
And your twos.
There's nothing wrong with my 2s.
Man, you still look like
You said that.
They call- Your G's are the
You're
best.
fired.
Fired from what?
Oh.
Any questions? Oh, better smile.
Is the camera still on? Delete this video.
New girl.
Why are there not any ions on the product?
They balance out.
It's not.
They just balance out.
Zero start. Might work out. That's what's for. All right, get out your notes. Get out your notes. Chapter 4. American history. Post-Civil War, the Reconstruction. What chapter do you think we're on?
We're talking about that one.
We've been on that chapter a long time.
I know, and his are
We're going from 4 to 13, so hang on. Okay, I still don't have a projector, so just look at your notes. Stop running your pie holes, please. Turn to page 5. Turn to page 5. Do you have something to add to the class? I can't hear you.
What are you doing?
That's not for this class. All right, activity series of metals. If you look at it, it's hard to see, but at the top are the most reactive metals. Lithium is the most reactive metal. Down at the bottom are the least reactive metals. They're less likely to form compounds and react with other elements. Okay? Any element on that list, any metal on that list, will replace from a compound a metal below it. What I mean is, let's say we have lithium metal.